Today, 7.2, the circle and the ellipse. We want to give you the equation of a circle and have you draw it. Then we're going to give you the equation of ellipse, have you draw it. Here's a circle. A lot of you may be familiar with this equation of a circle. And this is for a circle that is centered at the origin. In other words, h and k are 0, 0. The location of the center of a circle is x minus h, where h is your horizontal shift, y minus k, where k is your vertical shift, and r is your radius. So if you have a circle, it has a center, hk, and it has a radius. So here's an equation of a circle. Find the center and the radius, and then graph it. And you might be saying, what? That doesn't look like anything that we just did. We're going to make this into the equation x minus h squared plus y minus k squared equals r squared. And we're going to do this by running complete the square, not once, but twice. So I'm going to take this x squared and this x, and I'm going to put them together, and I'm going to get x squared minus 16x plus blank. Then I'm going to take this y squared and this y, and I'm going to put them together, and I'm going to say plus y squared plus 14y plus blank equals negative 32, where this blank is the same as this blank, and this blank is the same as that blank. So what goes in the blank? What is a? b divided by 2 squared. So you're going to take this middle term, the 16, you're going to divide it by 2, which is negative 8, and then you're going to square it, 64. So if I add 64 to one side, I've got to add 64 to the other side. And then what goes in for blank b? Take the 14, divide it by 2, 7, square it, 49, 49. And guess what you just created right here? That is a perfect square. It is x minus 8 squared plus, guess what you created here? A perfect square. X plus 7 squared equals 81, which is 9 squared. So tell me something about the circle. Where is its center? 8, negative 7. And what's the radius? Radius is 9. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, negative 7, and you're going to have a radius of about 9. When we talked about a circle, we have a formula that looked like this. I'm going to tweak this formula just a little bit. I'm going to divide everything by r squared. So now I've divided everything by r squared, and I get equals 1. This is the formula of a circle. We just divided everything by r squared, and everything's fine. We're going to take our nice circle. We're going to stretch it, and we're going to call this f1 and f2, and that's going to elongate our circle. And you no longer have a circle, you now have an ellipse. And this ellipse actually has two different radii. It has a radius in the x direction, we're going to call this radius a, and it also has a radius up and down, which we're going to call b. Our equation now becomes x minus h squared over a squared plus y minus k squared over b squared equals 1. This is the equation for an ellipse. What if a and b were the same number? You're right back to a circle. But now what we're doing is we're saying a and b can be different numbers. And that takes your circle and stretches it one way or another. If a is bigger than b, you have a circle that is stretched horizontally. However, if b is bigger than a, you have an ellipse that is stretched vertically. This is for an ellipse that is centered at the origin. And you'll notice that the equation is very simple. I wish they would have written x minus h squared and y minus k squared, because this is just a simplification of that, where h and k are 0. This is what we're talking about, this foci, or the focal points. The focal points are the locations C, where C is equal to the square root of a squared minus b squared. And remember, A was this distance, your horizontal axis, and B was this distance, your vertical axis. So that's how you find the focal point of the ellipse. Find the standard equation of an ellipse with vertices negative 5, 0, and 5, 0, and a foci, focal points, at those two locations. Then graph it. I'd like to start with the graph, and then we'll build up to the equation. It has vertices at negative 5, 0, and 5, 0. And it has a focal point at the location negative 3, and then 3, 0. It's going to look something like this, probably. But what we really would like to know is, what are these points? And so we know that A is equal to 5. That's this distance from here to here. C is equal to 3. And what we're looking for is B. So we know that c squared equals a squared minus b squared. Move some stuff around. So b squared equals a squared minus c squared, so b equals the square root of a squared minus c squared. So that means b is equal to the square root of 25 minus 9. And the square root of 16 is 4. So this point is 0, 4. And then there's a reflected point down below, which is at 0, -4. Once you have this graph, now go back and work on this equation. Oh, this guy is centered at the origin. So that means h and k are 0, 0. Awesome. X squared divided by 25, 5 squared, right? Plus y squared divided by 16 equals 1. That's your equation. So much easier to come up with that equation if you have a picture, if you have a graph. Much better graph than what I drew. Let's graph this ellipse and find out everything we can about it. We're going to have to run complete the square twice, just like we did before. So let's begin with the x's. So they take the 4x squared and the 24x, they put them together, and then they factor out a 4. And then they take the y squared and the -2y, and they put them together. And then they take the 21 and they kick it over to the left. What goes in the first blank? 9. So we're going to add 36 over on this side. And now move to the y. What goes in the blank? 1. So you say plus 1. So we're going to add 1 over on this side. So this whole thing's going to equal 16. So that x squared plus 6x plus 9 becomes x plus 3. Remember, because this becomes x plus 3, x plus 3, which is x plus 3 squared. The y's are also a perfect square, so that's y minus 1 squared, and then you get a 16. This is what's different from the circle. Now you're going to divide everything by 16. You want it all equal to 1. And so you divide everything by 16, and you get this. So tell me about this. Where is the center of this ellipse? -3, +1. That's the center. What is the horizontal radius? 2, right? Because this is 2 squared. What is your vertical radius? 4. So if I sketch this, -3, 1, 2, 3, +1. There's the center. I've got a horizontal radius of 2, 1, 2, 1, 2. And I have a vertical radius of 4. 1, 2, 3, 4. 1, 2, 3, 4. Looks something like that. This is your y-axis. This is your x-axis. Now there is one more thing we could have found. We could have found the location of the foci. So we found this length, which was our A length, and then we found this length, which was B. Notice that there's a focal point here, and we didn't actually calculate it. But you could have calculated it. You could have said, you know, c squared equals b squared minus a squared. What does the foci do? That is a great question. Planets, comets, all orbit in elliptical patterns. The Earth does not go around the sun in a nice circle. It goes around the sun in an ellipse.